All right, we've got Packet Tracer installed. Now let's actually do something with it. So let's take a look at addressing. So we're going to go over Mac IP version 4 and IP version 6. So Mac addresses, they are hardware addresses. Mac stands for Media Access Control, but it's also known as the physical address or hardware address of your network interface card. So every wireless card, every Bluetooth interface, anything that can do networking physically coming from the manufacturer has a unique MAC address. So that's stamped into the hardware. But IP version 4 and IP version 6, they're logical addresses. They're assigned to specific network adapters, and they can be reassigned later. So we'll go over that. I'll let you do some of the reading, but I'm going to really jump into the Packet Tracer portion to do the hands-on. We'll take a look at this stuff. So I'm going to launch Packet Tracer. Take a second to start up here. And I'll resize it so that I can see the instructions side by side with Packet Tracer. All right, we're going to add a computer. We're going to add a PC here. So we need to go to the End Devices main category, and the End Devices subcategory will be selected by default. And I'm going to drag a PC on here. So this is simulating a computer on a network. I'm going to add another one, drag and drop it. So I've got PC0 and PC1. Those are the labels. Click on those labels, and you have to click in the right spot. I'm going to click on Alice. If I click on PC1, it'll automatically let me change that name. If I click a little bit too high, it's going to pop up a window. I don't want that window to pop up right now, so I'm just going to close that window. No harm done. And just make sure you click on the right spot. So I'm going to click right on PC1. I'm going to call this Bob. So you have Alice and Bob, two names frequently used when we talk about cryptography. Alice and Bob want to send messages to each other, and often there's Eve, the eavesdropper, in the middle. So I've got these two PCs here on my small little network. So next thing we want to do is we want to connect these with a cable. We're just going to create a two-computer network here. So I'm going to click the lightning bolt category, the connections category, and the connections subcategory is selected. And we have a bunch of different cables that we can connect with. They represent real cables that you would use to connect devices in the real world. They don't necessarily look like what they would look like in the real world, but here we have this copper crossover. This represents an Ethernet cable that you would commonly use to plug into computers when you're using wired networking. And we'll use this dashed line. It's a cable where the wires are configured specifically to go from one computer directly to another computer. Don't have to stress too much about it, but that's what we're going to use. So once you click on that, notice the sign changes to the cancel. We don't want to cancel. It looks like a paintbrush. It's really the cable connector. So now if I click on Alice, it's going to ask me, okay, what do you want to plug this into? Well, it's an Ethernet cable, so I don't want to plug it into the USB ports. It's an Ethernet cable, so I want to plug it into the fast Ethernet. So I'm just going to click on fast Ethernet. And now if I move my mouse around, it's going to ask me where I want to add the second connection. I bet you can guess. We're going to click on Bob. Click on Bob, and I'm going to choose fast Ethernet. And we get these green lights. These green lights mean that we've got our connection established. I'll pause the video for a second while that motorcycle does its thing outside. All right, got the windows open. It's hot here in the summer. Got to let some breeze in. Okay, so we're good. We've got two computers on our simulated network here. They are cabled. Everything is good. All right, we are going to assign these computers IP addresses. And instead of letting them obtain their IP addresses automatically using the dynamic host configuration protocol, we are going to set these IP addresses statically, meaning we're in charge. So I'm going to click on Alice, and it's going to pop up Alice's computer configuration. And we can see on this physical tab here, we have a pretty crude representation of a desktop computer from 1985. Yeah, I've had computers that look like that. We are going to go to the config tab. This is the easiest way to get this done. And on the configuration tab, we've got a few interfaces here. We've got Bluetooth or fast Ethernet. I'm going to click on fast Ethernet because that's what I plugged into. That's what I want to change. And I'm going to change the IPv4 address to 192.168.1.25. And if I hit tab, it's going to fill in the subnet mask that it thinks I want. And in this case, it thought very well. That is indeed the subnet mask that I want. Whenever you set an IPv4 address, you have to set the IP address and the subnet mask together. The subnet mask just tells which portions of the IP address define the network and which define a host and individual PC's address on that network. So really what this is saying, this is the 192.168.1 network, and Alice is essentially number 25 on that network. She gets that 25. So the 0 in the subnet mask, if we line these up vertically, the 0 is the host portion. All those 255s, those are the network portion. So that's good. I don't have to click the save button or anything here. As soon as you enter it, like it's applied, so that's good. So we just want to make sure everything matches. You don't have to deviate from these instructions. Notice the MAC address here. This is the physical address that was given to Alice. So even though we're doing a simulation, Cisco pretended like this network card came off the factory floor and it assigned a MAC address here. So this MAC address differs from the screenshot in the instructions just because Cisco makes it somewhat random. So everyone's is going to be different. All right, I'm going to close Alice. I'm going to bring up Bob. And we're going to do the same thing. We're going to come to the config tab and fast Ethernet. I'm going to change the IP address. We're going to start off the same way. 192.168. My fingers are off by 1. 192.168.1, same as Alice. But instead of .25 for Bob, I'm going to say .50. When I hit tab, it's going to fill in the correct subnet mask, 255.255.255.0. What do those 255s mean? Don't worry about it too much, but it's got to be that way for this to work. All right, so let's verify connectivity. We did use the same subnet mask for both of them, so that's good. They're on the same network. So to verify connectivity, I'm going to open up Bob. And we start with the physical tab. We made our configuration change on the config tab. Let's go to the desktop tab. And this is like a very crude desktop, as if Bob had logged into this computer and Bob was using this computer. This is what Bob sees when Bob comes into the office and can use all of these fancy applications. It is somewhat Windows 3.0-ish. Like, it's pretty old, but it's a simulation. So yeah, it's going to be fairly bare bones. So on the desktop tab, we're going to open up the command prompt, and this is going to give us the command line interface. And so I should see this right here. And I can run this command ipconfig /all. And I can see information about the Internet Protocol configuration on Bob's machine. So I can see that Bob's IP address is 192.168.1.50. I see the subnet mask. I see Bob's physical address. So it doesn't say MAC address. Here it says physical address. Sometimes it might say MAC address in different operating systems. It might say hardware address, but it's all referring to the exact same thing. Again, yours will be different. We can ignore Bluetooth. We don't care about Bluetooth. Now let's try to test connectivity. I'm going to ping Alice. So what is Alice's IP address? Well, we set it to 192.168.1.25. And we get a reply. Excellent. Very excellent. That means these two computers can talk to each other. So they can share files, they can share printers, any resources they have on their computers, they can share them with each other because the network connection has been established. So the ping is a utility. It's part of the Internet Control Message Protocol, ICMP protocol, just to test connectivity. So that's excellent. IP version 4. Working just fine. But IP version 4 has been around a very long time. One problem with IP version 4 is that there are only 4.3 billion IPv4 addresses available in IPv4. So kind of a problem if we have more than 4 billion devices that need IP addresses. People realized early on that, oh yeah, we're going to run out of IPv4 addresses. So they actually designed IP version 6 to give us dramatically more IP addresses. One problem with IP version 6 and IP version 4 is they don't exactly play nice together. So you're kind of using one or the other. You can't just add an IP version 6 computer to an IP version 4 network and expect it to work. So it's been complicated. Most of the world today still uses IP version 4. We will be using IP version 4 for a very long time, side by side with IP version 6, even though IP version 6 is technically newer and better in many ways. So let's configure these computers to use IP version 6. So I'm going to click on Alice, and on the config tab, I need to select Fast Ethernet 0. And under the IP version 6 configuration, I am going to sorry, I'll delete the IPv4 stuff first just to clear it out, just to make sure that we're using IPv6 only. In the address, the format's going to be a little bit different. I'm going to write 2001 colon db8 colon acad colon 1 colon 25. In the prefix, I'm going to enter 64 there. So we deleted IPv4. We set the IPv6 address. This /64, the 64 over here, is kind of like the subnet mask in IPv4. The format looks a little bit different, but they're just big numbers represented using letters and colons. So Alice is good. So I'm going to close Alice. Don't have to click save or anything. It's saved automatically. Let's open up Bob. And I'm going to come to config, Fast Ethernet 0, delete all the IPv4 stuff, and I'm going to write 2001 db8 colon acad colon 1 colon 50. So all the 2001 db8 acad 1, that was the same for both Alice and Bob. The only difference was that 25 or 50 there on the end. So it's the network portion versus the host portion, really is what we're doing. So this is good. Bob has been saved. I could jump to the desktop tab right now. If you close Bob, no worries. I'm going to open Bob back up, then go to the desktop tab. And let's go to the command prompt again. So can we test connectivity to Alice's machine? Sure, let's try it. So let's ping 2001 colon db8 colon acad colon 1 colon 25. And we should get a reply. Yep, it worked. I was able to successfully ping Alice from Bob using IP version 6. So the addresses just look different, but from the user's perspective, it doesn't really matter. Honestly, if you're using IP version 4 or IP version 6, both of them work well. IP version 6 adoption has been somewhat slow worldwide, partially because it's not backwards compatible. About ballpark half of the devices in the world use IP version 6. I think the majority of them are cell phones. So if you're like in India and you're using a cell phone, your cell phone probably has an IP version 6 address. But if you're in a corporate network or in a home network and you check your IP address settings, there is a very good chance that you're just using IP version 4. And a lot of companies just say, we're going to stick with IP version 4 because it's widely supported and it just works. And we don't need all the benefits of trillions of IP addresses inside our organization. All right, so that's it for now. We added some devices, we cabled them, we set their IP version 4 addresses, we tested connectivity, we set their IP version 6 addresses, tested connectivity again. Both work just fine.